probability, probability. Probability, probability. Probability, probability. Probability, probability.
Probability is the chance of something happening. In this video, I'm going to use the example of weather. Alright, let's say we are wanting to know what the weather is going to be like for the upcoming week. At least the work week, that is, or school week. Alright, if we were given the weather report and we saw that Monday is going to be cloudy, Tuesday sunny, Wednesday and Thursday cloudy, and Friday either partly cloudy or partly sunny. So what if I then asked you, what is the probability of it being cloudy this week? Well, what I'm asking you is, what are the chances that it's going to be cloudy? Well, given that we're only looking at the work week, so just 5 days here, we have to first figure out how many days there are in total, which I just mentioned. There are 5 total days. 1, 2, 3, 4, 5. Now, out of those 5 days, how many days are going to be cloudy? Well, 1, 2, 3, and you could argue this one as well because there's a cloud there. So we could say 4 out of the 5 days are going to be cloudy. Now, when we're dealing with probability and we want to figure out what the chance is that it's going to be cloudy, we often deal with percents. So I need to turn this 4 out of 5, or 4/5, into a percent. To do that, I simply divide my 4 by my 5. And when I do that, I get 80%. So at least for this week, the probability that it's going to be cloudy is 80%. Or another way of saying it is, there's an 80% chance that it's going to be cloudy. Now what if I turn things around, and now I'm curious to see what the chances are that it's going to be sunny? Well, once again, I have 1, 2, 3, 4, 5 days total. And out of those 5 days, how many of them are going to be sunny? Well, I have Tuesday, and there is some sun here on Friday, so we can include that one as well. So 2 out of the 5 days are going to be sunny. Now, once again, when we're working with probability, we want to find what the percent is that something's going to happen. So we're going to turn this 2 out of 5, or 2/5, into a percent. So we divide the 2 by the 5. And when we do, we get 40%. So there's a 40% chance this week anyway that there's going to be sunny skies. And that's all there is to it. Tune in to the next video here where I'm going to show you how ratio
dice, dice,
card probabilities, card probabilities,
probability, probability,
Now we read probability in detail. First, tossing a coin. When we throw a coin, either a head or a tails appear on the upper face. So there are two conditions. One is head and second one is tail. If we throw a dice, there are 6 conditions. Comes 1, 2, 3, 4, 5, 6. So there are condition 6. Draw a card from a well shuffled deck of 52 cards. There are 1 shapes, 2 clubs, 3 hearts and 4 diamonds. Each are numbered in 13. So there are 52 cards, in which 1 king in 13 cards and 1 queen and 1 jack all. So total are 4 king in cards, 4 queen and 4 jack. There are king, queen and jack, also known as face card. So in cards there are 12 face cards. 4, 4, 4. Condition in a coin comes head. There are 2 total chance and 1 in favor to head. So there are possibility to come ahead is 1 by 2. In our dice, randomly take here 3. In a dice there are condition of comes 3 is 1 by 6, because 3 is only we take 1 times and total condition is 6. We take favor condition upon may total number of condition. And in cards, if we take a king, so there are 4 king and total numbers of cards is 52. So there are condition to come a king in cards 4 upon 15. We can write this 4 ones are 4 and 4 ones.
card probabilities, card probabilities,
Several examples using playing cards. Our first case is a card is selected at random, and what is the probability that it is a heart? To answer this question, we need to figure out how many winners we have divided by how many total. There are 13 hearts out of 52 cards total, so the probability of getting a heart would be 13 out of 52, which of course you could reduce to 1/4. The next question says, a card is selected at random. What is the probability it is a heart or a face card? We know there's 13 hearts out of 52. Face cards, Jack, Queen, King, 4 suits, clubs, spades, diamonds, and hearts. So there are 12 face cards. So probability of hearts, 13 out of 52. Probability of face cards, 12 out of 52. But what's interesting about this is there's some cards that are common to both. So which cards are both hearts and face cards? That, of course, would be the Jack of Hearts, the Queen of Hearts, and the King of Hearts. So there are 3 cards that are common to both hearts and face cards. So the probability of hearts and face cards would be 3 out of 52. Now our issue is or. We're looking for heart or face card. Probability of heart or face card would be probability of heart plus probability of face card minus the probability of heart and face card. And we've established these numbers in the earlier slides. 13 out of 52 plus 12 out of 52 minus 3 out of 52, or 22 out of 52. Now our next question is, if 3 cards are selected at random, what is the probability that all the cards are diamonds? So I need a diamond on the first, second, and third. Diamond on the first is 13 out of 52. We're doing this without replacement, so on the second go-round, there would only be 12 out of 51, since 1 diamond is gone, 1 card is gone. And on the third pick, third diamond, given the first 2 are diamonds, we'd be down to 11 diamonds out of 50. So if you want to do this multiplication, probability diamond on the first and diamond on the second and diamond on the third, we get probability diamond on the first times probability of diamond on the second given diamond on the first times probability of diamond on the third given diamond on the first and diamond on the second. So we have these numbers, 13 out of 52 times 12 out of 51 times 11 out of 50. And let's go to Excel to do that computation. So we need 13 out of 52. 13 out of 52. We need 12 out of 51. And we need 11 out of 50. And what I'm going to do is I'm going to go ahead and make each of these a fraction. So equals this number divided by this number. So that first fraction is 1/4, and doing the autofill, we get those numbers. We want to take the product of those 3, so we're going to say equals product. And the number we get is 0.01294. So the probability of diamond on the first and diamond on the second and diamond on the third is again about
Card probabilities. Card probabilities.